So in this video, we're going to review how to evaluate functions at a specific input value. So given a function written in function notation like f of x, you can evaluate this function at a specific value of the domain. So let's suppose we want to find the value of y equals 3x plus 4 when x equals 2. Well, we can rewrite that as find f of 2 when f of x equals 3x plus 4. So remember that f of x is what replaces y when your equation is a function. So just a quick reminder, so this is function notation, right? So whenever we have an equation that represents a function, instead of y, we write f of x. And that just kind of specifies that we're talking about the function f and that our input is x. So let's try finding the value of f of 2 when f of x equals 3x plus 4. So notice that what this does is it tells you a specific value of x that you need to plug into the function f. So what I'm going to do is I'm going to go to f, and to evaluate f of 2, I'm going to replace all my x's with 2. So that gives me 3 times 2 plus 4, and now I just need to simplify this. 3 times 2 is 6, and so I have 6 plus 4, and so that gives me 10. So f of 2 is equal to 10, and that's how you evaluate this function. So remember that order of operations is very important when you're solving these problems. So especially when you get to the step where you replace x with the number that it specifies and you're working on simplifying, you want to make sure that you're following order of operations. So now that given f of x equals 3x plus 2, let's evaluate f of negative 5, f of 9, and f of 2/3. So let's start off with f of negative 5. So f of negative 5 is equal to 3 times negative 5 plus 2. 3 times negative 5 is negative 15, so I have negative 15 plus 2, which is equal to negative 13. So f of negative 5 equals negative 13. Now let's try part B. So in B, it wants us to find f of 9, so that's going to be 3 times 9 plus 2. 3 times 9 is 27, so I'm going to do 27 plus 2, which is equal to 29. So f of 9 is equal to 29. And now let's figure out f of 2/3. So I'm going to replace x with 2/3 this time, so I have 3 times 2/3 plus 2. And so when I do 3 times 2/3, remember when I multiply fractions, I'm going to cancel any common factors, so I can cancel this 3. And so that's going to leave me with 2 over 1, which is 2. So I have 2 plus 2, which is equal to 4. So I can say that f of 2/3 is equal to 4. So now you can go ahead and pause the video and try doing this example on your own. So when we evaluate f of negative 3, we're going to go to 2x minus 5 and substitute in negative 3 for x. So that gives us negative 6 minus 5, which will simplify to negative 11. So let's try evaluating g of 4 given that g of x equals the square root of x plus 5. So I'm going to go ahead and go to my function and I'm going to plug in 4 for x, right? So this is the square root of 4 plus 5. So remember, I need to do the operation under the square root before taking the square root. So that's going to give me the square root of 9. And so the square root of 9 is equal to 3. So that means that g of 4 is equal to 3. So now you can go ahead and pause the video and try this similar example on your own. So to evaluate g of 17, you're going to go to g and you're going to substitute 17 for x. So we have the square root of 17 minus 1, which is the square root of 16, and the square root of 16 is equal to 4. So remember that given a function equation, you can evaluate for a specific value of x.